Welcome to The Explainer. We're totally shattering the illusion today that the technologies of the future are still like years away, because honestly, they're rolling out right now in the form of highly practical inventions.
So, what actually happens when science fiction becomes a commercial product? Let's dive right into this, because we're living in this crazy era where abstract concepts from the lab are becoming tangible, everyday tools that you and I can actually buy. We aren't just talking about theory anymore, right? We're talking about pure execution.
To really ground this in reality, just look at this massive number. Enterprise spending on generative AI hit a staggering $37 billion in 2025. To put that into perspective, $37 billion, that is literally more than the GDP of several entire countries. It proves, without a doubt, that this is a full-blown commercial market. The big money is shifting from experimental R&D straight into scalable, practical applications that businesses are actively deploying as we speak. In this explainer, we're going to cover agents and androids at work, hacking the human body, next-gen hardware and energy, inventions to cool the planet, and finally, adapting to the innovation era. Let's get to it. Kicking things off with Section 1, Agents and Androids at Work, the new digital and physical workforce. We are officially moving out of the chatbot era and straight into the agentic era, meaning AI doesn't just sit there and answer your questions anymore. It autonomously pursues goals and executes entire multi-step workflows. These agents maintain long-term memory, they interact with APIs, and they utilize verifiable outputs to do the actual heavy lifting work of a digital colleague. It's a real game changer. And on the physical side, get this. Manufacturing costs for humanoid robots dropped 40% in just a single year. That brings units like Unitree's G1 down to a highly practical $16,000 price tag. Guys, that's roughly the price of a used economy car. It means humanoid robotics are no longer locked away in billion-dollar automotive factories. At these price points, AI-driven physical labor is quickly becoming accessible to small businesses, local warehouses, and eventually, our own homes. Moving right along to Section 2, Hacking the Human Body, Clinical Reality. So CRISPR has totally evolved. It went from being a genetic pair of scissors to this highly precise biological search engine. Think of base editing like finding a single typo in a 3 billion letter book and just fixing it without having to tear the whole page out. Instead of making a blunt double-strand cut that could trigger some unwanted mutations, base editing corrects single mutations flawlessly. And the best part, it's being used right now to repair specific immune deficiencies and metabolic abnormalities. We are definitely no longer just theorizing about this stuff. We are tracking these precise biological interventions in clinical reality right now. Just take neurotechnology, for example. Brain-computer interfaces are actively enabling paralyzed patients to control computers entirely with their thoughts, all via these wireless, high-bandwidth implants. It is absolutely incredible. All right, let's shift gears to Section 3, Next-Gen Hardware and Energy, Powering the Future. The crucial point to understand here is the contrast between these two systems. Conventional liquid batteries are flammable and they're prone to leakage, which severely limits their high-capacity potential. But these new solid-state architectures structurally prevent thermal runaway, which is just a fancy way of saying they won't spontaneously burst into flames. This allows them to safely support high-capacity lithium metal anodes, which have a theoretical capacity nearly 10 times greater than conventional graphite. This huge shift to solid ceramics and polymers means we can finally pack in the massive energy density required for things like long-range electric vehicles and grid-scale storage. And we can do it entirely without those explosive risks. It's exactly the kind of completely practical invention that fundamentally redefines our energy limits going forward. Now, to connect all of this, we obviously need a major upgrade in infrastructure. And 6G, well, it isn't just about giving you faster phones. It's really the invisible nervous system that lets all these new physical AI robots talk to each other in real time. This next era of connectivity relies heavily on cloud-native, zero-trust networks. Basically, a highly secure, multi-layered framework that's fully capable of handling everything from holographic communication to instantly perceiving the environment right at the deep edge. We're also seeing the literal merger of AI and quantum hardware, and you've got to look at this benchmark because it is absolutely mind-boggling. Google's Willow chip completes calculations in just 5 minutes that would take classical supercomputers 10 to the 25th power years. I mean, wow. That is not science fiction. That is a verifiable benchmark achieved today.
By utilizing quantum error correction, they're gaining incredible advantages in totally practical fields like medical device simulation and materials science.
Okay, zooming out now for Section 4, Inventions to Cool the Planet, Scaling Climate Tech.
These definitely aren't just pie in the sky ideas on a whiteboard anymore. Scientists are currently using specialized filters to grab CO2 right out of the air at night, and they're using copper nanoflowers to convert those emissions into usable liquid fuels and plastics. Just imagine giant solar-powered sponges literally soaking up a planetary threat and turning those greenhouse gases into essential chemical building blocks. It's brilliant. But the big question is, can we actually build this infrastructure fast enough for it to matter? Well, history says yes. Just look at the explosion of wind and nuclear power over the last few decades. To stay on track for our climate targets, carbon capture and storage just has to mirror those massive historical scale-ups. And the data suggests that's entirely feasible if failure rates continue to decrease. We're looking at a projected 8-fold increase in capacity by 2030.
Finally, bringing it all back home with Section 5, Adapting to the Innovation Era, the Survival Trait.
Because AI has essentially commoditized traditional product development, taking processes that used to take months and compressing them down into mere days, your ability to rapidly discover and validate practical solutions is now a literal survival trait in the market. The barrier to entry hasn't just lowered, it is completely collapsed. With the cost of experimentation basically hitting zero and these incredible tools right at your fingertips, I want to leave you with a thought to close out our explainer today. The open source models, the hardware, the biological tools, the AI agents, they are all accessible to you right now. So the only real question left is, what are you going to build with them?